In this video, we'll look at integration visually. So integration actually simply is area. Okay, so let's say if you had something constant, which I'm going to call g, also representing gravitational acceleration. So if I have a constant acceleration, for example, if I have something that's constant, then integration up to, let's say, a point here t is simply the area of this. That's all. Okay, so if I draw the integral of g up to t dt, right, up to t, from 0 to t. So basically what it's saying is that at any point t, right, it will be g times t. Why? Because t is the base, g is the height, so g times t is the area. Okay, so gt, so y, if this is the integral of that, then integral of g is basically gt, which is a straight line in which the slope is g. Every step here is g up. Okay, so this is basically the integral of a constant. So integral of a constant is a ramp or a triangle, if you like to look at it that way, right? So what this means is that if I have a constant acceleration, then something, for example, like I call velocity v. So v is equal to, or I'll use the same color. So v is equal to your original g times t. Okay, so that's the linear curve that you get. And this is what happens if you drop a ball. So if you drop a ball, then the velocity of the ball keeps increasing. Think about it. If you drop the ball and you caught it immediately, that's your hand, then there would not be much speed when you caught it immediately. But if you drop the ball and after, let's say, one floor, you put your hand and you caught it, you will feel that the speed has really increased. And similarly, if you let the ball go on for longer, so the longer I leave the ball, the faster it's going to get. This much I think we know from our experience, and that's what's happening here. It's linearly increasing. Velocity is linearly increasing as the ball is dropping. This is not true of the distance, right? So for the distance is one more integral of. So that means the integral of velocity is what is going to give me distance. So this is the integral of velocity actually. Okay, so that usually is distance. So if you think about it, acceleration, speed, distance, what's happening. So here I need to take the area of, up to, let's say, some point t, I need to take the area of this. This is the area of a triangle. Okay, so the height of the triangle is of course v, and the base of the triangle is t, right? So half base into height, so half of vt. Okay, now v itself is gt. Okay, so basically my distance becomes half of v times t, which is half of v is g t square. So half gt square. Okay, so this is a parabola, right? So the distance is actually, as the velocity is also increasing, the distance that you are traveling in a certain period of time is constantly increasing. The slope of this is actually increasing. So the slope here was g, or whatever this time t1 was, and the slope here, because the velocity is changing, right? So here the slope is this velocity, and here the slope is the velocity here. So this is v1, this is v2. So the slope becomes, one step here will give me v1, one step here will give me v2. So it's increasing. The speed is constantly increasing, which means the distance I cover every second is constantly increasing. So this is a object under constant acceleration. It is also how the integration of a of something that is a constant becomes linear, and the linear becomes a quadratic. That also we can see here. And this is what gives us our all the formulas of distance and all that related to gravity. If there was an initial velocity, so that means if the initial velocity here, as we have seen, is 0, right? But let's say this was my 0 and I had an initial velocity u, right? So then it will become, v will become u plus gt. And when I integrate, the integration here, I should have used green just to distinguish, the integration here is ut. It's just a rectangle. This is t, height is u. So my distance would have been equal to ut plus half gt square or at square. Okay, this is the formula of distance that we usually use. So we can see that through integration we can describe a physical phenomena like a falling ball and what's happening to its velocity or speed, what's happening to its distance, what happens if the initial velocity is not 0, it has some initial velocity, that also we have taken into account. So this is what we have learned in this video. What happens to the velocity if there is a original velocity and then there is a constant acceleration, and what happens to the distance, original velocity and there is a constant acceleration.